And yes. Okay. So thank you guys. So good morning, afternoon, and evening, everyone. My name is Yama, and welcome to Crypto Tonight Ethereum Layer 2 Rollup episode. So this episode indeed is going to be not so easy to understand. So stop what you're doing, listen and learn from the Layer 2 experts. And they are Harry, the co-founder and CTO of Offchain Labs. Hi, Harry. And Alex, the co-founder of Meta Labs. Alex from Berlin. And Yao, head of research of MYKEY Lab. And Pan, the director of research from ChainNews. Hi, Pan. And by the way, ChainNews is also a Crypto Tonight exclusive media partner. Great to have you all here. So first, brief introduction. Let's start with Harry.
Absolutely awesome. Well, thank you for having me. I'm Harry Kalodner, as you said, CTO and co-founder of Offchain Labs and developer of the Arbitrum Rollup protocol, which is an optimistic rollup for scaling Ethereum with support for arbitrary EVM smart contracts. We're very close to finishing up development for our initial version, so we're kind of going to be heading towards mainnet towards the beginning of next year, and we're super excited to make L2 scaling practical.
Thank you, Harry. Next, Alex.
Hi, everyone. My name is Alex. I'm CEO and co-founder of Meta Labs. And we are working on a different flavor of rollup, a ZK rollup, which is based on modern cryptography and has all the interesting properties, essentially cryptographic assumptions aside, all the same security properties as layer 1. And we are also working on enabling generic smart contract scalability for Ethereum.
Thank you. Next, Xiang from MYKEY Lab.
Hi, thanks for having me here. And I'm Xiang, the head of research at MYKEY Lab, and I'm doing some research on layer 2 solutions and other topics in Ethereum. Most of my time I'm doing some research on rollup, especially ZK rollup. So yeah, thanks for having me here.
Thank you. Next, Pan from ChainNews.
Hello, everyone. Thanks, Yama. I'm Pan from ChainNews. ChainNews is a media and research institute of the crypto-native blockchain and fintech area. I'm very interested in the Ethereum ecosystem and especially the layer 2 infrastructure. We wrote many pieces of layer 2 progress, including the ZK rollup, optimistic rollup, Validium, Plasma, etc. Recently, we published a report of the latest rollup ecosystem mapping for the Chinese DeFi projects to reference what is the current status of the best layer 2 solution. So I'm very happy to discuss with Alex from Meta Labs and Harry from Offchain Labs directly. Thanks.
Thank you. Thank you, guys. So moving on to our quick panel warming questions. So first, congratulations. Ethereum 2.0 is finally live. And to Meta Labs and Offchain Labs, how is ZK rollups or optimistic rollups relationship with the Ethereum 2.0? Maybe Harry?
Sure, absolutely. So first of all, yeah, crazy excited to see Ethereum 2.0 phase 0 launching after a lot of years of research and development, and it's incredibly exciting. But it's certainly also a process, and it's going to take a bit of time before Ethereum 2.0 is actually kind of phasing smart contracts, scaling smart contracts. There's kind of multiple phases, of course. So we have phase 1 and then phase 2. Phase 2 is when kind of arbitrary smart contracts come in. But the really exciting thing from the perspective of someone developing rollups today is that rollups can take advantage of Ethereum 2.0 well before any other smart contract systems can. And so a big part of the Ethereum 2.0 roadmap at this point is the kind of middle phase, phase 1. And Vitalik has already actually published kind of prospective plans to kind of target phase 1 at enabling rollups. And the reason why that works for rollups and it doesn't work for other smart contracts is really straightforward and interesting, which is that rollups need a lot of data throughput, but they don't need execution. And so the phase of Ethereum 2.0 before it even reaches the ability to execute is already extremely helpful.
Thank you, Harry. It was a really good explanation, and I just want to add to this that the what Vitalik also shared in his presentation of ETH2 roadmap and adjustments, making Ethereum essentially a rollup-centric network, is that applications who adopt rollups today will be able to migrate to ETH2 without any hassle. Like even if there are modifications in the execution environments and like some special things which you would have to take into consideration when moving the code base to ETH2, if you are on a rollup and you are a part of a big rollup ecosystem, the ecosystem will migrate on its own and everything will work just exactly as it used to work for you now. So like this is the easiest way, and this is why Vitalik also said that it's probably going to be like this path for everyone. So like there will be no need to develop applications natively for ETH2 unless you really need like basic level, unless you are building your own rollup or something. But for most dApps and protocols, they will just start scaling with rollups today and then smoothly migrate to ETH2 as is.
Thank you. And Pema, would you like to add a little bit, like, for example, if the one dApp develop a layer 2 version, will it miss the advantage of the composability, how to interact with the layer 1 smart contract, since also the other two guys already mentioned smart contracts, and how to also maybe the interact with another layer 2 dApp.
Yeah, as we all know, the rollup is categorized as the layer 2 technologies, but everyone is pay a very good attention to how to what is the missing of the composability or the interpretability of the layer 2 rollups. So our question is how to interact, how to a layer 2 to interact with a layer 1 smart contract or another layer 2 dApp. I think Harry first.
Absolutely, yeah, and this is certainly an area I know that that Alex enjoys talking about, since this is an area where optimistic rollups kind of have some more difficulties than that ZK rollups do not. In optimistic rollups, there is a challenge period during which any user has to be able to challenge any sort of assertion or block on the network before it can be fully confirmed to the underlying chain. And so there are certain interoperability difficulties when communicating from layer 2 contracts to layer 1 contracts. While luckily, I believe that those will matter very little in practice, because what we can support very nicely is flows of liquidity. And we're working with kind of, there's a lot of great work going on in that field. Connext, for instance, is a great project that's kind of a state channel scaling, which is going to enable flows between all sorts of different layer 2 and layer 1 systems in order to smooth a lot of those gaps. And so that's kind of the way it is, and it's very interesting as we kind of push forward into this kind of new regime, seeing how that develops. The other thing to say is that we're hopeful that kind of we can minimize how much interoperability is needed, since interoperability is much more necessary for platforms that can only support a subset of use cases. So for instance, if you only support value transfer, it's much more important that you be able to interoperate with smart contracts running on a fully featured platform. Whereas having a fully featured platform, kind of migration into the rollup is going to probably be the best approach for many use cases.
Okay, thanks.
So I think I'll start by explaining how these things will work from the point of view of users and developers, so that our listeners have the full picture. So if you are on a layer 2 rollup, for example, optimistic rollup or a ZK rollup, then all applications that live inside this rollup can interoperate smoothly just the way they interoperate in Ethereum. So you will be able to like you migrate your contracts, and you can call methods of other contracts. They can call further methods, all in one atomic transactions seamlessly. Like inside ecosystem of like a single layer 2, everything works just as before. Now, if you want to interact with layer 1, then you have to pass a message to layer 1. To pass a message there, we have this difference. Optimistic rollups require 1 week or 2 weeks or whatever the security threshold delay. ZK rollups can do this after zero knowledge proof is complete, which will be like the latency of ZK rollups is going down to just a couple of minutes, maybe even under 1 minute. So like then you can pass a message and you can pass value. Now for value, like native value passing will be fast for ZK rollups, will be longer for optimistic rollups. Optimistic rollups can mitigate this for liquid tokens through the use of external liquidity providers. This cannot be mitigated for NFTs and for calling arbitrary contracts, which sometimes is also necessary. Like sometimes you don't just pass send some value, but you need to call some function, and you need to justify that you are calling this function from a certain state. So you need to pass certain state from the layer 2. So this will unfortunately require like 1 week in optimistic rollups. So I think these use cases won't really be used really well there. And also NFTs you cannot mitigate. You have to wait for this 1 week. Now for value transfers, so what it means from practical perspective. If you're using a ZK rollup, for example, you have a smart contract wallet, and Yao can talk about this more. You can today implement a smart contract wallet, or like simply just like wallet application with accounts living inside a ZK rollup, which can call layer 1 contracts with a very small delay, with very small latency overhead and very small cost overhead. So you're just gonna pay the cost of a normal layer 1 transaction, and it's gonna take you not like 15 seconds or half a minute, but like 2 minutes. But it's possible. And also protocols that live on layer 1 will have an option to migrate smoothly to layer 2 into the ZK rollups. And I think this is a very crucial point. So I really want to stress that. I believe that the migration from layer 1 to layer 2 will be gradual. These protocols are new, both ZK rollup, which is live for just since last summer, and optimistic rollups, which is still in the testnet phase, need some time to get validation and get more trust from people, because this is very new technology. We don't know, like there might be bugs, there might be some edge cases which we need to take into account. So it will pass, like time will pass, just like it happened for MakerDAO, for example. For the first year, Maker was like very small protocol with just few, like very little liquidity, but then over time it grew up to billions of dollars. So I think the similar thing will happen here. So we will have version of protocols, like DeFi protocols, for example, deployed on both layer 1 and layer 2. And then most users will remain in layer 1, but some users will start experimenting with layer 2. And with a growing number of users in layer 2, because it's obviously much cheaper, so we can afford to get more users, hundreds of thousands, millions of new users, they will start using the layer 2 versions of these protocols, like Uniswap, Curve, Balancer, and so on. And then the governance of the protocol can opt to move liquidity gradually from layer 1 to layer 2. So maybe in the beginning, the ratio is like 1 billion in layer 1, 10 million in layer 2, and then gradually it shifts over to layer 2. But whenever you need to move parts, like whenever a lot of users need liquidity back on layer 1, for some reason, maybe there is some liquidity mining opportunity, maybe something else, you just want to move them back. With ZK rollups, you can move them back instantly, right? So you can rebalance anytime. With optimistic rollups, it's going to be more like one-way road where you just move, it's flowing from one direction to the other. So the users will have to choose which flexibility they need, whether it's important or not, and then choose the protocols accordingly. Mm-hmm. And yeah, just to finish, if you want to interact with other layer 2 protocol, so like from one rollup to another rollup, it always goes through layer 1. Like no matter what, it always goes through layer 1. Even if you use state channels, the state channels always are rooted in layer 1. So like your like delay will be equal to the delay of moving funds from layer 1 to layer 2, and from layer 2 to layer from layer 2 to layer 1, from layer 1 to layer 2, unless you have liquidity in the other rollup, which connects another payment channels like this want to facilitate, then you could mitigate this. But then the liquidity has to be spread across all these protocols, which might be a bit of a challenge, but we'll see how that works.
So does it mean each layer 2 network is independent of each other? And to build the transfer the access between the different layer 2 network, they just have to go through the layer 1.
So unless you have liquidity in another layer 2, which can be immediately made available for you to use, then you will have to go through layer 1, yes. So all the layer 2s are rooted in layer 1. They all share the layer 1 as the basis for their security and as the canonical stakeholder.
I think just to add on there, I think that kind of the model that I use for kind of most layer 2s, and certainly kind of all rollups, is very similar to kind of the normal sidechain model, in that a rollup is it is in many ways a blockchain, not from a security perspective, but kind of in most other valuable ways. And essentially then what we're talking about is kind of there are different methods. There's some sort of specialized, optimized methods for bridging between kind of the rollup and the underlying blockchain, in this case Ethereum, that it's hosted on, and then sort of all of the lessons that have been kind of learned over the years from sort of generic blockchain interoperability, which is of course a massively interesting and exciting problem to a lot of people, can kind of truly be applied on top of rollups. And that's where we get into sort of the cross-chain atomic swaps and various primitives that have been made for kind of generic blockchain interoperability.
Thank you. And so then Hermes and Starware proposed their solution. So what do you think of them? And also, do you have a good plan?
Yeah.
Yeah,
so,
I just want to add this. Starware proposed conditional transactions. They think they can use conditional transactions to provide interoperability. And Hermes proposed massive migrations. So do you have some comment on their plans, or do you have any plans on the interoperability issues?
Harry, you want to start?
Sure, yeah. So I mean, this is kind of the ability to migrate is definitely kind of extremely useful, and kind of being able to do it efficiently in order to prevent user lock-in is quite valuable. It's quite a tricky problem, and it's interesting in that many of the solutions I've seen so far are kind of very focused on rollups that do exclusively value transfer. In value transfer rollups, where kind of every asset, there's the only thing in the chain are assets, and assets have kind of clear unique owners. Doing things like mass migration, where sort of every owner can opt in, works very nicely. For smart contracts, that becomes much tricky. If we are playing, let's just say, a game of chess, and there's a chess smart contract, actually kind of migrating the entire state and kind of knowing who has the option of migrating that state. Can either of the players migrate it? Can anyone migrate it? Can no one migrate it? Are kind of very difficult questions. And so I think we're spending a lot of time sort of exploring different strategies. I don't think there can be a generic strategy that makes everyone happy, but I think that, and I was just reviewing again the Hermes proposal this morning. Something like that could very likely work with Arbitrum Rollup, for example, with very few changes. Since the idea behind it seemed to basically be creating kind of a set of smart contracts that were aware of each other and could aggregate a large amount of funds that could be transferred together and kind of do a single transfer and then open those back up, which is a very cool solution. And yeah, one that I think could potentially work without, possibly without any changes to Arbitrum at all, for example.
I agree to that, and just want to stress that mass migration is indeed a crucial problem for rollups, because this is an an equivalent of a fork in layer 1. So like why this is important, Ethereum security is based more on the broad set of full node validators, thousands of users who can always decide to fork away if the validators start misbehaving, right? So like, this is way more important because we only have a small number of validators who are fairly centralized in some ways. So you always want the stability of users to initiate a user activated soft fork and like put a check this way on the behavior of validators. For rollups, the equivalent of this is, of course, mass migration, because you cannot have a fork of a rollup. You're always rooted in Ethereum, so your canonical state is equivalent to Ethereum canonical state. I think it's possible. Like we have a design in Meta Labs for zk-sync to enable mass migrations, despite having generic smart contracts, and we also want to support Solidity smart contracts, which like with the legacy contracts being able to migrate to zk-sync completely without modifications. So we want also the legacy contracts to work and be able to support this mass migration. But we will publish the designs as soon as we're ready, as soon as they're complete and peer-reviewed. But this is definitely possible. There is no fundamental difference here. And also to comment on Stark versus conditional transfers, it's also not something fundamental. It's like not very different in essence from the idea of state shells, for example.
Yeah. So the diversity of the layer 2 system, for example, makes the wallet integration more difficult. Perhaps we wish to deliver a unified experience to our users. Do we need a EIP to reach some standards? And MYKEY Lab actually is a smart wallet.
Yeah, I can explain. Yeah, maybe I can explain the problem to make you informed. As you see, we have investigated many layer 2 systems about the technical principles, dev teams, APIs, SDKs, security audits, which spend a lot of our time. We don't want to bet on a specific project, but integration is an engineering problem which contains many complex details, even dirty details. So we are waiting for a greater maybe, but currently there's no one, something like a Wallet Connect, as you know. So we can integrate with many layer 2 systems and with little effort on engineering. So do you have any plans or some solutions for the problem?
Harry, you want to start?
Sure, yeah. So yeah, wallet support obviously being kind of the face of how most users interact with kind of blockchain systems is critically important. That's why, and I think this is good. I think this is true of both the zk-sync and Arbitrum. We've focused a lot on sort of making using kind of the same addresses, same kind of and I'm not sure, you know, speaking just about Arbitrum, same exact transactions. And so kind of using Arbitrum can be as simple as selecting an alternative provider. Now that to me is really a stopgap measure, because dedicated wallet support, I think, that can actually sort of understand the idiosyncrasies of sort of layer 2 scaling systems, and potentially and hopefully relatively soon be able to enable alternative signature types like BLS signatures, as seen in Ethereum 2.0, which are going to be able to bring costs down massively, is really critical. And I know I think Barry Whitehat from the Ethereum Foundation is leading a big charge to sort of to standardize the BLS format that I think of rollups are interested in using on Ethereum 1.0 today. And sort of, I think the EIP system is really great for kind of bringing everybody together and focusing on a standard, and that wallets can't feasibly long-term have to focus on integrating every different scaling solution that comes along. We need sort of generic support. And so, yeah, we're definitely kind of actively engaging on finding the right way to do that, and would love to kind of be involved in a standard.
agree to that. There will be definitely efforts to bring standards, and the ease of use will be just as like you connect a different wallet connect provider, or you have extended methods in your Web3 injected wallet in the browser, like MetaMask. MetaMask will also support snaps probably early next year with extensions, custom extensions built into them. But for us, we're also using a different signature scheme, which is much cheaper in zero-knowledge circuits, and we found a solution to enable support of any wallets today. So I can share my screen. Oh, I can't share screen. Okay. But if you go to Curve homepage, there is a link to Curve testnet for ZK on ZK Sync, and you can see how it works there. So essentially, it's similar to a open authentication protocol like Google Connect or Facebook Connect, where you click on Connect Wallet, a separate tab will open in your browser, which is hosted by ZK Sync and which will hold the keys. And then you will, like, every time you need to sign a message, you will go to this separate page, confirm there, and go back. And the security is also similar to this Facebook or Google authentication schemes. But of course, it's going to be a lot more secure if the keys are not handled by the browser, but are stored, never leave the wallets, which we will see with the widespread adoption of these new APIs. It's important that users can start using it today without any hassle.
Yes, agree. Thank you, guys. So moving on to the next question. So the layer 2 nodes, we mentioned this a little bit before, actually. So the layer 2 nodes and replayers, the archive replayers or coordinators require extremely high computational resources. And so how can we make it decentralized?
Zero knowledge proof nodes.
Yeah. Alex, do you want to?
Yeah, sure. So interesting thing about zero knowledge proof generation is that it's self-validating. So you actually, your security does not depend on this. So why would we decentralize? Decentralization is not the goal per itself. What is the goal is the resilience against extremely powerful attackers, fairness of the protocol, so that like rules are enforced and there is no single point of control, and censorship resistance, that like no big powerful actors can control what's going on there and prevent certain user transactions. So with regard to zero knowledge, like if you have a blockchain like a rollup, which does all of this in a decentralized way, and then delegates the proof generation to some actors who might or might not respond. If they respond, you will always be able to validate the response, because it's a proof which you can just verify. Like the smart contract will decline it. So there is less of an issue of proofs being generated in the cloud or by a smaller set of users. But there are efforts also on the way to make it more decentralized, just to increase the resilience, just like not to have a situation where a few actors would generate the proofs and then all of a sudden they are all shut down by their governments and cannot produce proofs anymore. And for these cases, there are protocols such as Golem that enable decentralized computation, and they can be used, like any of these protocols can be repurposed to generate proofs. But they are separate from the consensus and they're separate from the full nodes, which do not require, like they don't have a requirement to generate the proofs. They are always happening asynchronously off chain.
Thank you, Alex. So Xiang, do you have anything to add here? Or we can just move on to the next question.
Yeah.
Oh, Pan, yes, please.
Pan, yeah. You're
okay,
muted.
Okay. Yeah, Alex. So do you mean the validation is trustless? So it's costs very little to verify if the data ZK rollup data on the chain is correct, but the computation of to generate ZK snarks proofs is maybe centralized. Do you mean that?
It's not centralized because anybody can produce it, right? Like we still have a full permissionlessness. Anybody can go and deploy it in the cloud. So what an important point here is that like you as a validator have an option to either delegate it to somebody through a decentralized market, or just go and deploy your own cloud instances in Google Cloud, Azure, Microsoft Azure, GCP, Baidu platform, and so on and so on. Like those computational platforms do not need to be trusted. Like this is very important.
Okay.
So you can go and deploy and generate the proofs on demand. You don't have to own this hardware. You don't have to reserve it for a long period of time. You can just in time send a job, produce the proofs, and get it back, either on these cloud providers or through a decentralized platform. Just like for, I think it's less crucial to decentralize it at this step. It will be more crucial to decentralize it at the next step, because I think that these cloud platforms actually already have too much power. So we need to be able to move away from them and like not give Google and Microsoft and Baidu control over all these assets. But if you look at Ethereum full nodes, most of them are running on AWS, and so like it's a similar situation. It's just like Amazon cannot control all these nodes. They don't know what's going on at every single point of time. You can always deploy it, generate, like run some job, and like they will not know from all the millions of users who use the platforms who is doing what, who is generating proofs or doing something else. Right? But it's really important that trustless.
Okay. So right now the generation process is CPU friendly or GPU friendly or ASIC?
It's both. So like we have a CPU based solution. We have experimented with GPUs, but it gives you some cost benefit, some small cost benefit, maybe 20%, or like 50% or something, but like the latency is still comparable to CPUs. And we also have a FPGA based solution. And this is very interesting because the cost is smaller by a factor of like, I think 3, like it's 3 times cheaper. But that's not as interesting as the latency decrease by a factor of like 10. It's really, really fast. And especially if you combine like using the recursive proofs, you can combine them in a certain way to increase parallelism of proof generation. And you can have a block of 10,000 transactions generated in like under 1 minute. This is really, really powerful. Like with CPUs, it's a bit more like you can also parallelize this a lot, but like with you just like factor of 10 longer. So FPGAs are also cloud friendly, and they can be used with Microsoft Azure, Google, not Google, AWS, F1 instances, and also Baidu will open soon their FPGA matrices for custom images. And yeah, so like you will be able to do the same thing there as you do with CPU. Just to send a job, compute it on demand, only pay for the computation time, and then get the results back, verify, and submit to Ethereum.
Thanks. And Yao, you can ask.
Yeah, I just want to add from the wallet perspective, the decentralization means permissionless and trustless. And in the worst case, as Alex just mentioned, suppose all the nodes are shut down. The wallets, we don't want to rely on a third-party service like infra. So in layer 1 system, we deploy many nodes to sync from Ethereum and broadcast our transactions to the network. So in the worst case, we just wanted to broadcast our users' transactions using our own nodes. We just want to have the ability to propose the transaction to the network. And that's the decentralized meaning for the wallets. And I think every wallets they do have this concern. Yeah.
Sure. Just to add in here, just to kind of loop back in optimistic rollups. I think the reason I don't have a ton to say here is because optimistic rollups don't have this issue at all. That running kind of that generating and verifying proofs in I mean, it's very comparable to running an Ethereum node, so it's not exactly a lightweight process, but it's something that's kind of does not involve kind of too large an amount of computation, and so can be kind of relatively easily decentralized without any issues.
So I have a question to that. That means that every user is supposed to run its own optimistic rollup node, or how do you see these dynamics? Like the more transactions is happening on a single optimistic rollup, the higher are requirements to run the full node. So do you think it will be more like every application that chooses to use optimistic rollup will opt for its own deployment? Like how is this dynamic going to play out?
Yeah, absolutely. I mean, I certainly hope that kind of major stakeholders in the rollup will run their own nodes, simply to get kind of higher security guarantees, and the fact that it's not particularly expensive to run the node and is kind of quite easy to set up, I think will kind of incentivize that fairly heavily. I certainly don't expect everyone to run a node, just like very few people run Ethereum nodes today. Many people rely on Infura. Most likely, many people will also rely on kind of hosted provided solutions for optimistic rollups as well. And so I think it's kind of very similar to the current ecosystem.
Yep.
Guys, so next question. So Yao actually mentioned minor extractable value, this term MEV. So so what do you think about that? And is it possible to prevent front running on layer 2 system?
Harry, you want to start?
Sure. Yeah, this is a big one. So MEV, which kind of is I think most easily thought about as, well, I mean, there are many forms of it, but I think the easiest one to think about is front running, where let's say you see some trade in transit, and that you could put in a trade. If you could put in a trade immediately before that one, you could have kind of or sandwich it between two of your trades. You could earn a lot of free money if you can do that with guarantee. And so to kind of start with the current situation in Ethereum today, is that miners basically have full control over the contents of blocks they produce. And so any miner could kind of look at the transactions they have that are kind of currently in transit, not yet included on the chain, and insert whatever of their own transactions they want when they create the block. And so that's the current situation. And so then the next question is there, what can we do about it? And I think there are a lot of sort of interesting approaches. There was recently a really interesting initiative by Phil Diane, one of the co-authors of the original academic paper studying MEV, which attempted to essentially just decentralize the harvesting of MEV to prevent scenarios where there's kind of one miner, for instance, that's much better at it than anyone else that could be quite dangerous. There are a number of other solutions that have been proposed. I know that the Optimism team proposed the MEV auctions proposal. I can't speak too much about that one because I don't really like it. It involves basically incentivizing. It involves basically creating an auctioning off the right to a single party to kind of arbitrarily control transaction, which does allow value capture, but also I believe would make the problem of minor extractable value much worse. Since that party kind of would be optimized to be greedy, since they are the highest bidder for this position. I think ideas like that are quite dangerous. One idea that I think has a lot of merit that kind of at Offchain Labs with Arbitrum we're currently pursuing, although I don't think this will be in place for our initial launch, is the idea of basically building upon a relatively new idea, which is Byzantine fault tolerant consensus with fair ordering BFT, most consensus systems in general don't actually provide very nice ordering guarantees. Many systems like, Tendermint, for example, the entire system is decentralized, but control over ordering is not, because that's not one of the security things that are guaranteed. Whereas my co-founder Stephen Goldfeder, who was actually also on the original MEV paper with Phil, published these kind of a new style of BFT systems recently. And what we would like to do is essentially decentralize out. What we think we can do is decentralize out ordering on a much more fine-grained timescale. And I'm going to hand waving a little here because, of course, this is a quite deep technical area, which should allow essentially a significant reduction in MEV. Since one of the main factors in how easy it is to harvest ME is how long you have to do it. It's quite tricky to do all of the math and calculations necessary to know exactly what transactions to create. And so if we can kind of limit the amount of time that any party has to do that, we can significantly reduce how much MEV is harvestable.
This is really interesting. I'm looking forward to see how that plays out. I'm afraid it will, like as you rightly said, it can reduce the impact of MEV on layer 2 system. And by the way, it's really important to solve this problem for layer 2s because they are going to be sufficiently less decentralized, at least in the beginning, than the layer 1, just because of there is a lot less value to be gained and a lot less players than the miners in layer 1 and Ethereum. So the problem, at least initially, if you don't do anything, it can get worse by a strong factor. But the problem with the fair ordering is that your blocks are necessarily have a minimum possible granularity, right? Simply because you need to account for the latency of submitting data from, let's say, Australia to Beijing to New York. You're limited by speed of time by double latency, double ping. So, and this time is a lot more than is necessary to actually compute the results of the transaction, because this happens locally and it's really, really fast. So if you have a huge transaction on Uniswap where some whale dumps a lot of tokens, you can immediately know that this is an opportunity to extract value, and you can insert your transaction as a miner immediately at that point. So that's why we believe that at Matter Labs that from information theoretical perspective, you can only prevent it completely if you actually obfuscate the contents of the transaction entirely. And this is possible with zero knowledge proofs. They are silver bullet. So what you can do is called time-locked encryption, where you can put a transaction in an encrypted envelope, submit it to the miners, who will include it in the block and commit to this block and have all the signatures collected for that block long before the contents of that transaction is revealed automatically through solving a VDF puzzle. So a VDF puzzle can take 30 seconds, but the blocks are 3 seconds long and so on. And this way you can completely prevent MEV, eradicate it. And this is what we believe will be our approach to this problem.
I have yet to see any VDF-based time lock that can actually have that level of precision in how long it takes to unlock, due to basically, for a little explanation for how this works, I mean, and Alex, correct me if I'm wrong here, but basically you kind of generate a cryptographic challenge that takes some amount of computation to sort of reveal the message. And so the kind of timing constraints around sort of how long it takes to open up are based around expectations on how long it will take to perform all of those computations. And they're done in a way that are not parallelizable. And so kind of you can assume that these computations have to be done sequentially, which means that the more requirements you put on, the longer it'll take. However, actually kind of knowing optimally, knowing that that somebody else doesn't have a system that allows them to perform these computations faster than you, is quite difficult. I know this comes up in Ethereum 2.0 as well, and I know that there's been work done to create ASICs to actually perform this, but it's a problem that has never been solved that I've seen in any deployed system. It's beautiful theoretically, but I'm a little dubious of how it works in practice. But I'd love to see it work.
Well, this is actually pretty simple. Like, first of all, this is a crucial part of ETH2. Like, if you like, and you can use the same VDF function, which is going to be used for ETH2. So we will be pretty sure that we have the best efforts. Like, there's a lot of funding, a lot of research, a lot of advancement recently in implementing these VDFs. And there's going to be a broad distribution of this VDF hardware with chips. I heard proposals of like producing thousands of these chips and giving them to people, like giving it in small pieces that you can carry with you on the keys, putting it on satellites, and so on and so on. So like it's going to be well decentralized, and it's very simple. Like you just have very simple computation, and you bring it to the limits of your processing power, and you put a huge margin on it. Like you put like, even if someone is able to perform the computation 10 times faster, which is unrealistic, like even if it's 10 times faster, they still will be behind the time which is necessary there. And it's widely peer reviewed. A lot of teams work on this. It doesn't need to be ASIC. It can be FPGA, because the FPGA is behind ASIC just by a small margin, since you don't use external memory. Everything happens on this chip. It never leaves the chip. You don't have to go on the bus and communicate with memory externally. So like ASICs will be worse by a margin of like maximum 2x, not worse. So like everybody can review. I have great trust in this technology. And if you don't have trust in this technology, then you probably won't have trust in ETH2, because if this can be broken, then ETH2 is vulnerable to the collusion of miners who can like manipulate the randomness beacon and manipulate the chain there. So if ETH2 is successful and broadly adopted, then this thing will can be trusted and can be used also for unlocking these transactions.
That's great. Yeah, no, I mean, I hope it all works out great. And I'll certainly say that, like, I think optimistic rollups will likely, take advantage of the exact same approach. I don't think that I think that basically that approach, is most likely kind of fully compatible with any rollup system, which is great.
Absolutely, absolutely.
Love to see it work in practice.
You will just have to embrace zero knowledge proofs, because people will be like, you'll need to generate zero knowledge proofs to prove that the transaction under this envelope is actually encrypted transaction, not just some garbage which validators commit to and cannot decrypt. And you also need some hardware experts to
and if these solutions work, they'll become kind of standardized and generalized, and most likely not require like a mat. Once they're deployed, I'm not saying we'll have it at the same time as you guys, but if you get it working, we'll have it 4 to 6 months later, most likely. But I think and that zero knowledge proofs are awesome, and I think that there's if ideas like this work, I think there's very, very likely going to be sort of high, optimistic roll-up systems that also make use of zero knowledge proofs to prove kind of particular properties. In adding optimistic elements to ZK rollups does not make any sense. Adding ZK elements to optimistic rollups makes a lot of sense, because kind of these validity proofs can sort of be slotted in wherever they're useful. So I mean, I think there's a lot of useful tech here.
Thank you so much. Very good. So to our last question. So Pan, would you like to ask the question about the token economics and to
we know there is a node operator between layer 1 and layer 2 to provide service. So how to build a tokenomics or cryptonomics to incentive the node operators to provide the high quality service? Is it necessary to have a native token in the system?
So First of all, like node operator, at least for Arbitrum, like kind of there's a few different types of participants in the network. So I mean, there's kind of there are validators that kind of are verifying blocks or maybe proposing them. That's fully decentralized. They're kind of that can benefit from incentives, but it's not totally necessary. Basically, kind of since it's relatively easy to run those, kind of the purpose of kind of incentivizing them is mostly for kind of guaranteeing liveness of the network. So guaranteeing that blocks will actually be produced. And there will be incentivization for that, but it does not need to be kind of a large financial incentive, because they're kind of both a combination of significant non-financial incentives and the fact that it's relatively cheap to do. There's kind of general sort of, and that's, you know, that's akin to mining in Ethereum. Then there are kind of general nodes in the network. So kind of RPC endpoints. And that's in Ethereum kind of one akin to sort of everybody who's running a node and not mining. Those I think kind of don't require incentivization at all. Or you know, put another way, are externally incentivized. There will certainly be kind of node providers like Infura, who kind of have external payment relationships with users to provide node services. But that's something kind of that the core system doesn't need to handle at all. The last component, which is kind of the most in need of good incentives and is the most difficult, is kind of for rollups that want to offer finality on the, and this is kind of a big topic that I'm just glazing the surface of, that want to offer finality faster than Ethereum. The way they do this is by having kind of some party that orders transactions. And that's the place where I think incentives are most important, because that party has might have a lot of power. And we're kind of proper, you know, through a combination of sort of decentralization and potentially through through some sort of governance, has to be sort of mandated. And this is, I think, the area where sort of tokens and incentives are most interesting and kind of being explored the most, because essentially there you have a party that the preference is always to fully decentralize. And I think the more decentralized you are, the less the less you need kind of fancy incentive systems. And so kind of the incentives are mostly in sort of places where there might be centralization, making sure that whatever party has power actually behaves well and behaves honestly.
Thank you, Harry. Okay, so I'll add our perspective for ZK Sync. We see it as a very simple situation. In a rollup, someone has to sequence transactions and produce the zero knowledge proofs for them in ZK rollup case. And this is some work which needs to be done. Our concern is to have it decentralized as to solve these censorship and reliability problems. So we need some permissionless way to govern the participation in this process. The way we do it is we will have a ZK Sync token, and there will be consensus at layer 2, which will also serve the purpose to have like faster transaction confirmations, just for usability of the users. You don't want to wait 30 seconds. We can actually, since we don't depend on security of these validators, we can do it like every three seconds or something. And once there is a consensus on some block, the validators agree on who is the leader for that block, a block producer, and this block producer will produce the zero knowledge proof and submit it to mainnet. And this participation is like the tokenization is the most natural and straightforward way to govern a permissionless participation in some protocol. So of course we need a token for that. And we believe that the fees which the validators will collect for the blocks will be sufficient incentivization for them, because there's going to be a lot of fees. In Ethereum, last summer, the Ethereum fees reached $200 million per month. That's a lot, and that's a lot just for a small number of users compared to the potential hundreds of millions of users of crypto worldwide who are going to come to these networks once we are successful with the rollups and we enable the throughput for them. So we believe that this number will be eclipsed by the future figures, which we will see. So there's going to be a lot of incentive for people to participate in this consensus.
Thank you
Thanks.
so much, Harry and Alex, for your explaining and sharing. Very, very insightful. I think this panel is more like a you asked me panel to you guys. We asked you too many questions, and I have to say thank you to Pan and Yao as well, because this episode is very technical. So before the panel already, I asked them to be my co-host. So thank you very much. So anything which is great takes time. So let's be patient. Eventually, no one cares, or no one really understands how it works, but everyone will use it. Thank you all. Thank you, and bye.
Yeah, bye.
Thank you.
Thank you, everyone.
Bye-bye.
Bye-bye. Bye-bye.
Thank you. Bye-bye.